Hey, do your thing. Hey, fresh out the house.
When studying solutions, it's often important to find the concentration of solute dissolved in solution. And there are three major ways to calculate this. You can use molarity, molality, or molar fraction. The first and most common way to calculate concentration is molarity, and it is given with the unit capital M, and is defined as the ratio of the moles of solute over the liters of solution. Another common way to calculate concentration is molality. Instead of capital M, it is given by a lowercase m, and it is, once again, the ratio of moles of solute, but instead of liters of solution, it is moles of solute over kilograms of solvent. Another form of concentration that is a little bit less common is molar fraction, and it's given by an x. It is the ratio of the moles of whatever you are studying. It could be the moles of a solute, the moles of a solvent, whatever you're studying. So the mole of x divided by the total number of moles in the entire solution. First things first, I'm going to show you how to calculate concentration using molarity. Once again, this is the ratio of the moles of solute over the liters of solution. So in this problem, we are given 36.45 grams of hydrochloric acid is dissolved in 1 liter of H2O. So let's see. First, we can identify HCl as the solute because it's being dissolved in H2O, and we are given grams of HCl, which has to be converted into moles. So first, we are given 36.45 grams of HCl, and we're going to put that over 1. What we're going to do is we're going to use dimensional analysis to get rid of the units of grams of HCl. So looking at our periodic table, we can calculate that the molar mass, or the mass of 1 mole of HCl, is actually equivalent to 36.45 grams of HCl. And if you don't know how to calculate this, you can simply find the molar mass of hydrogen and add it to the molar mass of chlorine. So we know that 1 mole of HCl is equal to 36.45 grams. So what we're going to do is we're getting rid of the grams of HCl because those cancel out, and what we're left with is the units moles of HCl. So now we equals, and what we're going to do is divide this, and a number divided by itself is equal to 1, and the only unit we have remaining is moles of HCl. Next, we've got to remember that molarity is moles of solute over liters of solution. So what we're going to be doing is dividing the moles of HCl. So we're going to do 1 mole of HCl over 1 liter of H2O. And so that's 1 liter of the entire solution. So 1 liter H2O. And we're going to divide this, and you are going to get 1. So in other words, the molarity of HCl is 1 molar, and you'll often see it like this. 1 capital M and the solute. You could say 1 molar HCl. What I'm going to do next is show you how to calculate concentration using molality. So remember that molality, little m, is equal to the moles of solute over the kilograms of solvent. So in this problem, we have 2 moles of HCl is dissolved in 1 liter of H2O. So we already have to calculate m. So let's write m, little m, is equal to moles of solute, which is 2 moles of HCl, hydrochloric acid, divided by, next we need to find the kilograms of solvent. In our problem, it says that we have 1 liter of H2O. Now, you can remember with water that the density of water is 1. Meaning that if you have 1 liter of H2O, you actually have 1 kilogram of H2O. This is because if you have 1 milliliter, you have 1 gram of H2O. So our kilograms of solvent will just be 1 kilogram of H2O. And you can do that 2 divided by 1 equals 2. You're going to do little m. 2m hydrochloric acid. Go. Next, I'm going to be showing you how to calculate concentration given molar fraction. So we are going to use x as our unit, And remember that it's equal to the ratio of the moles of whatever you're calculating and divided by the total number of moles in the solution. So in our problem, we have 2 moles of hydrochloric acid is dissolved in 1 mole of H2O. Now for these 2 examples, we calculated moles of solute on top. But for molar fraction, we're going to calculate the moles of solvent. So I'm going to calculate the molar fraction of H2O. So we know that the mole of X, or the mole of H2O, is equal to 1. We have 1 mole of water. So I'm going to say we have 1 mole of H2O divided by the total number of moles. So let's see. We have 2 moles of HCl and 1 mole of water. So we have 2 moles of solvent plus 1 mole of, we have 2 moles of solute divided by 1 mole of solvent, and that's going to give us 3 moles total. So total number of moles is equal to 3. So we can do 3 total moles, and we can get that X, our molar fraction, the molar fraction of water is equal to 1 over 3. Now I'm going to be showing you a common concentration problem that might appear on your next test. Problem says, calculate the molality of an aqueous solution that is 5.24 molar NaHCO3, or sodium bicarbonate. The density of the solution is 1.19 grams per milliliter. Now, what is the problem asking? It is asking us for the molality of the solution. Remember that molality, with the little m, is given by moles of solute over kilograms of solvent. We're also given that the solution is 5.24 molar NaHCO3. And remember that molarity, is given by moles of solute over liters of solution. So what we know is that our solution is 5.24 molar. So what this really means is that we have 5.24 moles of sodium bicarbonate over 1 liter of solution. Because remember, it's just moles of solute over kilograms of solution. This will give you 5.24. So let's try and convert this to grams. What we know is that 1 mole of sodium bicarbonate, is equal to 84.008 grams. So these are going to cancel out the moles, and we're going to be left with an answer in grams. So 5.24 times 84.008 gives us 440.2 grams of NaHCO3 in our 1 liter of solution. I'm going to erase this. Next, what do? We know that our density of our solution is 1.19 grams per milliliter, meaning that in every milliliter of our solution, we have 1.19 grams of sodium bicarbonate. So instead of giving ourselves grams per milliliter, let's try and blow the solution up into liters. So let's move this decimal place over 3 times. What we'll get is that we have 1,190 grams in 1 liter of the solution. So this is how much our entire solution weighs. How many grams is in the entire solution? We know that it's 1,190 grams. However, in 1 liter of the solution, we know that we have 440.2 grams of sodium bicarbonate. So what we can do is we can subtract the total number of grams, 1,190, minus the grams of solute, which is 440.2, and you should get about, you should be getting about 749.7 grams of solvent. And our solvent, this is an aqueous solution, so our solvent is H2O. So this is grams of solvent. Remember that molality is kilograms of solvent. So we can convert this by just moving our decimal place over 3 times, and we should be getting 0.7497 kilograms of H2O. Next, let's remember that we're supposed to be calculating molality, and it's the moles of solute over kilograms of solvent. So molality equals, we know we have 5.24 moles of solute, so 5.24 moles of solute over our kilograms of solvent. Remember, we have 0.7497 kilograms of H2O. 0.7497 kilograms of our solvent, and you should divide this, and you should be getting our molality is equal to 6.99. Hope you guys enjoyed.